So welcome back. We're going to amp this up to two-step inequalities. So again, we have these four different inequality symbols. We have the less than symbol, is greater than, is less than or equal to. That's kind of a compound statement. Is greater than or equal to, that's a compound statement. So it's got two conditions there. Don't forget, with inequalities, they're just like equations as far as strategies go, but there's just that one little exception. Remember, if we multiply or divide by a negative number on each side of the equation, or in this case, each side of the inequality, we must flip the inequality sign. So if I multiply, if each side is multiplied or divided by a negative number, don't forget that that inequality sign has to change direction, otherwise we lose the truth, and the problem ends up being backwards. So we need to do that. So remember, just like two-step equations, when I solve this inequality, I want to go after that negative number first using a zero pair. So I added 3 there to zero that out. So I end up with m over 3 is less than or equal to a negative 6 and a 3 gives me a negative 3. Remember these, a negative 3 and a positive 3 will just zero out. And again, to get m by itself, since there's division here, that's a signal to me to multiply by 3. Remember, you got to do that on both sides. Excuse me. Multiply on both sides. These 3's divide out. M is less than or equal to a negative 3 times the 3 is going to be a negative 9. Notice again, I multiplied each side by a positive value. That does not affect the inequality symbol. It does not flip there. So what I need to do is locate where the negative 9 is. So I'm going to put my 0 over here. And we'll count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got a negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Positive 1, positive 3, positive 5. Notice you don't have to label every number, just label enough to kind of get the information across. So I don't have to label every tick mark. I got to be less than or equal to a negative 9, so notice I have to be equal to. Remember, that's that condition where you use a solid dot. It's close-ended. We include that endpoint in the solution. It's part of the answer. So negative 9 can work. And less than or equal to, I would shade to the left. Also note with these inequalities, this inequality sign also could be like a little arrow. Notice how it's pointing to the left. It's kind of tell you to shade to the left. So if you have your variable on this side, this inequality symbol will actually tell you which way to shade. It's pointing to my left. That's kind of telling me to shade to the left because, of course, less than is to the left. So it should make sense. So notice again how we represent our solution as an inequality statement, and we also graph that on a number line. You'll be expected to do that quite a bit. So solving this inequality, remember with equations you have to remove the parentheses first. Combine like terms, distributive property. I needed to multiply the negative 4 through the parentheses. So negative 4 times a negative 4 will be a 16. Negative 4 times x will be a negative 4x. And I have a greater than 56. So notice that when you multiply through the parentheses, that then removes the parentheses out of the problem. Now we're ready to go to our two-step piece, which means we want to get rid of this negative 16 using a positive 16. So negative 16 and positive 16 will zero out. That negative 4x slides in. I have greater than, and 56 plus 16 would be 72. Now to get rid of that x by itself, I have to get rid of that negative 4. I've got to divide each side by negative 4. Notice again, I divided both sides by negative 4. That's that signal that I have to flip the sign. So my next line is, I'm going to mark these negative 4s out. I have x. Instead of the greater than symbol, I'm going to flip it to a less than symbol. And how many 4s go into 72? I'm not really 100% sure there. Let's see, 4 into 72. I don't want to put it there. I'm going to have to sneak it up here. 4 into 72. 4 goes to 7, what, one time? 4 goes to 32, 8. So it looks like 18. So 72 divided by negative 4 would be then a negative 18. Since we only have one negative in the problem, remember when you divide odd number negatives, it stays negative, and even number negatives, it's a positive answer. Since we only have one negative, it's going to flip to a negative answer. So x is less than or equal to a negative 18. So on my number line, I'm going to count by twos. So -2, -4, -6, -8, -10, -12, -14, -16, -18, -20. Notice I have a less than symbol. Less than is considered an open-ended solution. That's not part of the answer. So to exclude the -18, I use an open circle to say -18 is not part of the answer. Less than means, again, I would shade to the left. So my answer would be looking something like that. So again, we have an inequality statement and a number line to describe that answer. So any number that's less than -18, if you put that in for x, it should make a true statement. It's always a good idea to test that. So over here, I need to solve for x. Zero out the -4 with a +4. So I have a -11x. The -4 and the +4 will zero out. It's greater than a -15 and a 4 would give me a -11. To get the x by itself, I make that -11 disappear. I need to divide each side by -11. And the -11s will divide out. But notice again, I divided both sides by a negative number. To keep it true, I have to flip that inequality symbol. So that greater than symbol, it has to flip over to then a less than symbol. And a -11 divided by -11 is going to give me a +1. So you'd end up with x is less than 1 as your solution. So I have to be less than 1, so I'm going to have an open circle. I don't include the 1. Less than is considered an open-ended solution. We don't include that endpoint. Less than means I have to shade to my left. So your solution would be everything. And make sure you shade in that arrow as well to say it just keeps going on and on forever. So you'll see that marked that way on your multiple choice questions like that as well. So again, we have an inequality and a number line to describe my solution. It's always a good idea to test a number that's less than 1. You know, 0 is less than 1. Does 0 really work? So if you put a 0 in, that actually falls out. Is -4 greater than -15? Yeah. -4 is greater than -15, so I'm feeling pretty good about my answer. So you can always test a number that's actually pretty easy. Or also can kind of just, notice how 0 is not part of the answer. On this problem, if I put 0 in, it should make it a false statement. Okay? Which means I shaded on the right side of the solution. So sometimes if you get confused on shading, just test 0. If it's part of your solution, it should be true. If it's not part of your solution, it should be a false statement. So that's some food for thought. Thank you.